Hi there. Thought we would take a look at some more practice with the fundamental theorem. We're also looking at properties of definite integrals. So let's take a look. I've got a few problems here. First of all, we're being told that the area, remember, we interpret the integral as the area. We're told that the area from 2 to 6 of f of x is 10. That's going to be important for us. And then we're also told that the area from 2 to 6 of g of x is -2. So we're going to find the value of area from 2 to 6 of f of x plus g of x. So remember, our definite integrals tell us that we can actually split those two apart and just use the sign in between them. So this would simply be 10 plus -2, which would be 8. Okay. Now, when we split them in number 2 with the integral from 2 f of x minus g of x, we actually can move those coefficients in front of the integral when we split them up. And so now we have 2 times the area from 2 to 6 of f of x, which we're told is 10, minus 3 times -2, since that is the area of g of x from 2 to 6. And so I get 20 plus 6, or 26 here. Take a look at number 3. Notice that our integral goes from 6 to 2, and we have 6g of x. So if we're going to flip those bounds around, which we want to, we need to put a negative in front. And then we can pull that 6 in front of the integral. And so we get -6 times -2, which would give me +12. Okay. Now, a little different when we are being asked to divide. It doesn't quite work that way. You can't just divide the areas. So this one is actually not possible. Our separating of the integrals only works with addition and subtraction. So we have to be real careful with that. Okay, for the next set, we're told that the area of f of x from -2 to 4 is -6. And we're told that the area from -2 to 4 of g of x is 4. So let's see what we have here. We have the integral from -2 to 4 of f of x plus 4. I'm going to go ahead and split this into two integrals. Now, the first one, we're being told this. We know what the integral from -2 to 4 of f of x is. It's -6. But the 4 here, we have to do the antiderivative, which would be 4x, and then we evaluate with the bounds. So I've got -6 plus, and now we're doing the bounds here. So 4 times 4 would be 16, minus 4 times -2 would be -8. And so I get 10 plus 8 is 18 here for my answer. Okay, let's use a similar approach for number 6 here. I'm going to pull the 3 in front of the integral. And then I'm going to use a separate integral for x dx. Okay, so the integral from -2 to 4 of g of x is 4. So I've got 3 times 4 here. And then the antiderivative of x is 1/2 x squared. And we'll have to use our bounds from -2 to 4. So I'm going to use my bounds with this second piece. So I've got 3 times 4 is 12, plus, let's see, 4 squared is 16 times a half is 8, minus -2 squared is 4 times a half is 2. And so I end up with 18 again. All right, let's look at number 7 then. Again, we'll split up this integral, bringing the half in front. And then we'll use an antiderivative for this 3x squared dx. Okay, so area from -4 to negative 2 to 4 of f of x is negative 6. So I have 1/2 times negative 6. And the antiderivative here would be x cubed, and that goes from negative 2 to 4. So we've got negative 3. Now plug in your 4. That gives me 64. Minus, plug in your negative 2, gives you negative 8. And so I've got 61 plus 8 gives me 69. So good work with that. Remember, the calculations here are pretty simple. You'll want to make sure that you're really understanding the analysis and the properties of those definite integrals are going to help you with these types of questions on the AP exam. All right, so notice we're being given the derivative graph. And so we're being asked to find the value of the area from 0 to 7. So think about what that area is. That's all of this area in here. Okay. I would probably divide it up. I've got a trapezoid. I'm sorry, a triangle. I've got a trapezoid. I've got a rectangle. And then I've got another trapezoid. Okay. So let's do those separately. The first triangle, I've got 1/2 times the base, which is 3, times the height, which is 2. Okay, then let's do the trapezoid. 1/2 times 1 here, and then add the bases. 2 plus 1. Then let's do the rectangle. It's a 1 by 2. And then finally the trapezoid again. So I've got 1/2 times 1, and then add the bases. 1 plus 4. Okay, so let's add all those up. Here I've got 1/2 times 3 times 2. That gives me 3. Here I've got 3 times 1/2. That's 3 halves. Then I've got 2. And then I've got 4 plus 1 is 5 times 1/2 is 5 halves. So 3 plus 2 is 5. 3 halves plus 5 halves is 8 halves, which is 3. So I get 8. Okay. Now, look at number 9. We're saying if the function f of x is at 0 is equal to negative 3. Let's see if that helps a little bit. What is the value of f of 3? So to do this, we're going to have to set up the integral from 0 to 3 of the derivative. And we know that the antiderivative of the derivative is the function from 0 to 3. Okay, now this side we already know. We can calculate this from the area from 0 to 3. That's the triangle, remember? So that's 1/2 times base is 3, height is 2. And now use our bounds on this side, f of 3 minus f of 0. So 1/2 times 3 times 2 would be 3. We're told f of 0 is negative 3. So it looks like 3 equals f of 3 plus 3. So f of 3 would have to be 0. Okay. Now let's look at 10. Um, we'll set it up similar. We're going to do the area from 3 to 7. Notice I choose these values based on the value I'm given and the value I want to find. So that's how I determine my bounds. Antiderivative is the function. Okay, from 3 to 7, that's from here to here. So we already did from here to here. So that was 8 total. Minus, but if I take off this triangle, remember this triangle was just 3. So I know from 3 to 7, the area is going to be 5. Okay, plug in our bounds, f of 7 minus f of 3. So I get 5 equals, now f of 7 I want to know, but f of 3 I'm being told is negative 1. So that's plus plus, and so f of 7, I'm going to subtract 1, gives me 4. Okay, remember, this is kind of like a back door using the fundamental theorem to get some values for the function. Then we have the graph, a different graph, but still of the derivative. We want to find these values. Don't forget, f of negative 2 is 5. I always like to highlight that because I know that's probably going to be important. We want the value of f of 0. So I'm probably going to do the integral from -2 to 0 of f prime. I know the antiderivative is the function, and we're going from -2 to 0. Okay, now this area is the area from -2 to 0. That's this triangle. So that gives me 1/2. The base is 2. The height is 4. And then plug in your bounds. F of 0 minus f of -2. Okay, so this area here is going to be 4. And we're told that f of -2 is 5. So f of 0 must be 9. Okay, let's do a similar approach with 6. We're looking for the function value at 6. So we'll go from -2 to 6. And we know that antiderivative again is the function. And let's see our area from -2 to 6. Okay, so we've got this triangle that's positive. We've got this semicircle that's negative. So let's do them separately. The triangle would be 1/2. The base, it looks like 4. And the height is also 4. Now minus, and we'll do the semicircle. It looks like the radius here is 2. So that's 1/2 pi times 2 squared. I did the half because it's a semicircle. And that's the function at 6 minus the function at -2. Okay, 4 times 4 is 16, times 2 is 8. 2 squared is 4 times a half, and that's minus 2 pi. And then f of 6, and then we're told f of -2 is still 5. So I'm going to add 5 to this side. That gives me 13 minus 2 pi equals f of 6. So I like this work with the fundamental theorem and that back door. It's really nice to keep. Uh, it's one that I find students don't do as well on the AP exam. So if you're aware that it's coming, something you need to be looking for. These are great practice problems for that. Now, there are 2 AP questions that are really nice for this topic that I will link the solutions to below. So it's the 2003 problem number 4 on the AB exam. Oh, sorry, there's 3 of them. It's the 1998. Let me make sure you can see that. The 1998 AB number 3. I'll also link those solutions below. And the 1999 AB exam number 3 as well. These are great problems to practice with this topic, and I will link a video to their solutions down in the description. Thanks for watching, and as always, don't forget to hit like and subscribe. That way you get a notification every time a new video is posted. Bye-bye for now.